happening in the world today? Like, why is anybody here? Why does security matter? And if you look at how the world is starting to change, you think about, how are things changing? We know that there's, 35% year-over-year increase in adoption of cloud services. What does that actually mean, though? It means that your application architectures are changing, right, to take advantage of all of the new kind of things and innovations that are happening. So you have elastically scalable services. There we go, thank you. Elastically scalable services that are resilient, that are scalable, right? They're repeatable, so you want to use code. You can reuse code 80% of the time. You just change that little 20%. You want things that are repeatable, reliable. But what about security? Right? Security has to really be part of that. And if you look at the complexity of networks, complexity of, say, your cloud infrastructure, complexity of security, all of those gaps in visibility cause risk to the business in general, right? Because there's so many things. How do you actually start to pull it all together? And while convergence sounds like a great idea, convergence often means that there is more complexity being built in. So you really need to start to have end-to-end visibility. And then we can talk about, right, cyber attacks. You can name a million stats. Everybody, I think, here is hopefully fairly well aware of kind of the threat landscape, the different types of attacks out there. If you look at the latest, say, Verizon data breach report, the #1 breach vector, there you go, this last year was web applications. Because a web application is open to the internet. So #1 is web applications, #2, email. Again, because it's directly open to the internet, you need that traffic coming in to be able to get mail, to be able to get users to connect to your applications. So you can't close it off to the world, right? You need everybody to be able to get in. And so if you look at other statistics, you have 80% of the assets that were breached, they were servers. Of that, 15% from last year, right, up to 55% of those specifically were application servers. So how do you really deal with all of these changes, deal with changes in the threat landscape as your application architectures really start to change? Well, if you think about a data center, right, that's the whole point of this talk, is to talk about security in the data center. What is a data center? Right, a data center is there to host applications, to host services, and to host your data. But if you look at how things are changing, right, applications, well, more the services, right? Services you would host in your own data center, say for your end users. Exchange. Anybody run an Exchange server ever? SharePoint. I was a SharePoint admin, reformed. They were a huge pain, right? And so a lot of the services you would run yourself and that used to sit in your data center, they have been SaaSified, right? Microsoft now offers it as a service, and it's much easier to buy it from them, let them run it, because they are the masters, right, and the best experts in that application itself. So they run that service. Same thing with security services. You have things like SASE, right? You can now run firewall as a service instead of backhauling all of your traffic to your own data center to then have a security stack. You let somebody else do that for you, right? You can let Juniper do it with their SASE cloud, right? Secure web gateways with CASB, with DLP. So you have all of these services that you no longer have to host in your own data center. So what does that leave in the data center of tomorrow? Applications that you are creating, right, for your own end users, and data that the applications need to access. But one of the other big things, if you think about what does an application need? It needs processing power, it needs connectivity. Like at the core, you need those two things, right, for an application to run. 5G makes hyperconnectivity a lot more possible. So now we want to get everything as close to the edge as possible. If you're my user, I want that data, right, and I want to process that as close to you as possible, and I'm going to come over here. And if you're my user, I'm going to process that data as close to you as possible. 5G, right, connectivity, that really helps make that possible. Well, what it does is it spreads your data all over the place. And so from a security perspective, how do you deal with that, right? Get my clicker here. And so we think about applications, right? Again, applications and data are what we're trying to secure here. So if you think about how application development has changed over the years, we go from 30 years ago where if you wanted to create a new product, you needed a lot of specialty, right? You needed sometimes months, if not years, to create a new software product and bring it to market. market. Nowadays, you can do that sometimes in weeks to days. You have an idea for an application, you want to make a mobile game, sure, go ahead, right? You can do it pretty quickly if you're smart enough, and you can get to market really easy because guess what? You can go get compute power on AWS or Azure or GCP, right? Whoever gives you the best deal, whatever makes sense for the type of application you're developing, you can get there faster. So if you look at why is anybody prioritizing, right, modernizing their whole application development program, well, a lot of it goes down to different trends, right? Say the rise of remote working. Everybody's working from home. It's important that, it's nice that we're all here in person, right, today, but for the last number of years, we haven't been able to be. So creating products that allow people to connect to one another has become hugely important, which has driven consumer demand, right? Zoom became huge in the very beginning of the pandemic. And so you see a rise in competition of all of these different kind of connectivity applications that help the remote workforce, because at the end of the day, being able to serve things quickly to your users at a reduced cost helps, right, your business. So that's really the end goal for anybody. The business, you want to be able to provide growth with digital efficiencies that help accelerate your kind of digital transformation. And on the technical side, that means you need to deliver software at scale and velocity. So how do you do that? Well, you're going to start to change your processes, and you go from, right, waterfall types of development methods to agile to having more DevSecOps, where you have combined teams that are really trying to bake security into the entire setup. Same thing with the ops side. Everything's kind of moving into the development side. You go from application architectures that are monolithic pieces of code running on a single physical server to virtualized services and now microservices running on containers or even serverless processes that start to enable, again, the application so you can get the reusability that you're looking for. Your infrastructure and hosting goes from, again, single servers to a data center to now the cloud, and that could be a private cloud, that could be a public cloud, and now even to multi-cloud, where a lot of companies are starting to go. And then lastly, what does this have to do with security? Well, how has our cybersecurity posture changed over the years? When you have everything living on a single, bare metal server, it's a lot easier just to stick a firewall in front of it and you're good to go. But as everything starts to spread out, you have more distribution, you start to add in tools, right, that pool all of the data flows together, that give you visibility across multiple points of connection and multiple security tools. And so you have, right, SIM and SOAR tools that have been introduced. And then lastly, we kind of get to today with Zero Trust. Well, what does Zero Trust really mean, right? So if you think about what Zero Trust is, it's really about not trusting anything, right? I need to know what those assets are, and then create kind of micro perimeters around each one that details out how are workloads communicating with one another, how is the data being processed and connecting to those workloads, who's connecting in, is it a user internally, is it a developer that's making changes, or an operations person who's maybe putting a new version of an OS on a server, or is it, right, a device and an end user that has no kind of authentication coming in? So you need to know all of these kind of main assets, figure out what they are, who they are, and then you create policies. But that becomes really, again, difficult at scale with the amount of distribution. So you really need a lot of automation and orchestration to help leverage, right, all of the visibility and data you have coming in from a million sources. It's not possible for one human being to kind of understand all of that. So being able to pull all of that and have those resources kind of give you interesting insights that help you figure out how to best secure all of your different assets. And so then, of course, how do you do that? Well, you can look at it from a couple different key points, right? So the first is kind of looking at your on-prem data center, your private cloud, where you have different devices running, whether they're physical servers, virtual servers, devices right within there, even workloads. All of those are connecting then to, right, outside entities, users coming in to actually see the applications, or also data now transiting right from your private cloud to a public cloud, or from one public cloud to even another public cloud. So pulling all of that together with visibility, with analytics, with automation tools, so that you know always where are those data transactions and where do your workloads sit. To the core, those are the two most important things in your data center. So to be able to sit down and start securing this, looking at what Juniper can kind of do, is we kind of look at it from 5 main use cases. The first being your DC WAN gateway. This is your tried and true, right, firewalls. Who and what can connect into those resources that are being hosted in your data center, right? North-south traffic control, we got it. Then going into looking at how are your applications connecting to one another, how is data being exchanged between, say, your on-prem data center and your cloud, right? Looking at then, maybe you have some applications that are running in your physical data center, connecting into a colo in Equinix, that then gives you your cloud connect, right, into AWS and GCP. So knowing that you can not only get the visibility into those data flows, but you can actually inspect them because you can no longer trust them just because they're internal data flows between your kind of centers of data. Doesn't mean you can automatically trust them anymore. Trust, but verify what's in there, right? So doing inspection there. Then going into your intra-DC and public cloud, really you're looking at that east-west traffic, right? That's flowing in between all of these workloads. How are you actually getting visibility into it and looking for attacks? Because again, there will be times where an attack gets through, obviously, but how do you limit that blast radius, right? And creating, again, those micro perimeters around the smallest assets possible in each one of your kind of data centers. And how you do that in kind of your own, say, private data center versus a public cloud infrastructure, same concepts, but how you do that, the constructs start to change. Are you looking at, say, creating virtual firewall instances everywhere that have IPs right attached to them? Or are you looking at how do we do this with tags, right? In AWS, we have security tags, or GCP, right? You can use those, but it's the same, at the end of the day, it's the same kind of idea, but a little bit different how you get there. And then the very last piece is workload protection. How are you able to actually find 0 days within the application workload itself? Looking at how the code is executing in real time and stopping just the malicious piece from actually executing so that you know that you can protect those internet-facing applications, which are your most vulnerable asset. So if you look at how all of these kind of come together, you can see that you have your key points of protection, the DC firewall within your gateway, between all of your kind of centers of data with the DC Internet Connect and Cloud Connect, up into the public cloud. A lot of this is your north-south, right, traffic inspection, using tried and true kind of methods with IPsec for secure connectivity, using AppSec or IDP, right, to look for known vulnerabilities within those traffic flows, threat intelligence being shared out everywhere, and we do that really well, right? Things like IDP, Juniper has actually been doing it for 20 years collectively, if you didn't know. And we do it really well. If you look at all of our third-party tests, we come out as the most effective vendor for doing that on a firewall. But beyond that, that'll get you part of the way there, but as you start to move into, say, the public cloud, you can still use a VSRX, a CSRX, sitting again as that kind of north-south gateway, but how do you really start to get, again, visibility where you're going to lose it? Because the network doesn't have everything, right? So what about between those workloads? If it's not transiting the network where a firewall can see it, you lose visibility, but now you have things like Juniper Cloud Workload Protection that will give you that last mile of visibility and stop those threats as well. And then at the very top, you have things like Apstra and Security Director to pull it all together. Because at the end of the day, you have all of these kind of perimeters you're creating, and you need something to help orchestrate all of that together and make sure that traffic not only flows from one place to the other, but is inspected, right, for traffic. So we are able to give you kind of segmentation across the network, from the network level to the workload level, and then even into the cloud, using the right kind of constructs that make the most sense and give you the best visibility, with all of the elements of Zero Trust built in, from edge all the way to the application. And the last thing I'll just tap on here is if you think about how the world is evolving, right? There are a lot of different groups with different directives. You have security analysts, you have network operators, and you have developers that all have to work together to make this infrastructure work, right? Your applications are hosted on the network and secured by the security team. But if that model worked, and we had the best tech in the world to solve all these problems, we probably probably would have already done it by now. But it really takes people working together. And so finding technologies that not only help do the security, help do the networking, help your developers, right, that's important, but finding something that actually helps them all work together better. So security is built into the network, so security is built into your development life cycle is really one of the most important things, and changing the way that we're doing it, because what we're doing today doesn't work all that well when it comes to application security. You hear day after day how many breaches there are, how much money it costs, and there's a million statistics you could bring up, but if there was a technology that fixed it, I think everybody would probably be at that booth. So it's really about finding technologies that give you kind of the end-to-end visibility and help your teams work together better to solve that security issue. All right, and that's it. Any questions?